So we're going to go over the questions that we missed. This was the absolute worst question I've ever seen right here. 38% accuracy, right? The majority of us got this wrong. What the heck is going on? This was an absolute value equation. It wasn't even an inequality. Let's go and review this. First of all, whether you have an absolute value equation or an inequality, like a greater than or less than, it's the same thing. You want to isolate the absolute value first. In other words, you don't want this 2 right here. And this is truly a 2 times. You don't want the multiplication of 2. Now, yesterday when I walked around, I saw some students multiply. That's wrong, right? When I say isolate, that means get it by itself. Get rid of everything. You don't want to multiply the 2 in there. You want to get rid of the multiplication of 2. How do you get rid of something? You do the opposite. The opposite of multiplying is dividing. So you're going to divide by 2. It's going to cancel. What you do to one side, do to the other side. So now you have the absolute value of 4 minus x, close absolute value, equals negative 3x. At this point, you need to continue working. Some people might think, wait a minute, when you have the absolute value of something equaling a negative number, you could just stop and say no solution. That is true if it were the absolute value of something equaling a negative number, but it's not a negative number. You have an x, so you have to keep going. You can't just say no solution right there, okay? So if this x was not there, if it just said equals negative 3, yeah, stop and say no solution. But it doesn't say equals negative 3, it says equals negative 3x. So we must continue and do both the positive and negative situations. And let's review how to set those up. How do you set up the positive situation? You write it exactly the way it is without the absolute values. So it's going to be 4 minus x, just write it out, 4 minus x equals negative 3x. Identical. You don't change anything. Identical, but you just don't write those absolute values. Now, the negative situation, it's the same exact thing, 4 minus x, but you're going to change, you're going to flip the equal sign. And if you flip the equal sign, if you take that equal sign and flip it, it's still going to say equal. But you're also going to change the sign of the right side of the inequality or equal sign. So this negative 3x is going to become positive 3x. Okay? So if you're thinking, why the heck am I going to flip the equal sign if it still says equal? Because that's what you're going to do if it said less than. If it were a less than symbol for the negative situation, the less than will flip and become greater than. Or the greater than will flip and become less than on the negative situation. Are you with me? Okay. So now let's solve both of them. And for some reasons, you guys got confused right here with the x's, right? You have x's on both sides. So it's not like, oh, I want to get this x by itself. I want to get rid of the 4. No, that's wrong. You want to get x by itself on one side, and you have x's on both sides of this equal sign. So let's get rid of one of the x's. I want to get rid of this minus x by doing the opposite, plus x. What you do to one side, you do to the other side. You're going to end up with 4 equals negative 3x plus 1x is negative 2x. And that's really saying 4 equals negative 2 times x. So if you want to get rid of that multiplication of negative 2, you're going to do the opposite of multiplying, which is dividing. What you do to one side, do to the other. Divide by negative 2. So your answer will be negative 2 equals x. Negative 2 equals x. Okay? And you could write it x equals negative 2. I'll do that in a bit. Let's solve the negative situation right now. Likewise, I want to get x by itself on one side, but I have x's on both sides of this equal sign. So I want to get rid of one of them. I want to get rid of that minus x by adding x. And what I do to one side, I do to the other. I will now have 4 equals 4x. And that's really saying 4 equals 4 times x. And to get rid of the multiplication of 4, we divide by 4. What I do to one side, I do to the other. I will have 1 equals x. X equals 1. So here are my answers. X equals negative 2, maybe. And x equals 1, maybe. Now, why do I say maybe? Because you still need to double check your answers, right? As a matter of fact, let's go back and look at the actual question right here. Whoops. The multiple choice had both answers, the negative 2 and the positive 1. And a lot of people, 4 people picked that. But you need to double check it, right? Now, what do I mean by double check it? You need to plug it in to see if it works. So if you plug in a negative 2, and you could go to the original, but it's more math to do, or you could go to the isolated one. It's a little easier. If you plug in a negative 2 right here into the isolated one, what is 4 minus a negative 2? That's really 4 plus 2, which is 6. If you plug in a negative 2 over here, negative 3 times negative 2 is also 6. So what does that tell you? That this works. X equals -2. That is an answer, for sure. But when you test the other one, x equals 1, and you plug that in right here and here, you know it's going to be incorrect, because when you plug in a 1 right here, it's going to say -3 times 1, which is -3. And we know that you can't have the absolute value of something equaling -3. So this is what we call an extraneous solution. So you don't have that as an answer. It's only x equals -2. Yay? Okay. So like I said, the majority of us got this wrong. Only 38% of us got it right. Hopefully you understand how to do it now, and you could retake it Monday after school. Let's take a look at this one. Only 47% accuracy. More than half of us got this wrong. And this one was two inequalities separated with the word or. So here it is rewritten down here. We're going to solve both of them. You want to get x by itself. You want to get rid of the -3 first, then the multiplication of 2. So we're going to get rid of the -3 by adding 3. What you do to one side, do to the other. Rewrite it. 2x is greater than 18. That's really saying 2 times x is greater than 18. So you get rid of that multiplication of 2 by dividing by 2. And what you do to one side, do to the other. You'll end up with x is greater than 9. Okay? Let's do the same for the other. The other has the x on the left side of the inequality. You want to get rid of the 3 and the multiplication of -7. Let's get rid of the 3 first by subtracting 3. What you do to one side, do to the other. Subtract 3. You have -7x is less than 14, which is really saying -7 times x is less than 14. Let's get rid of that multiplication of -7 by dividing by -7. What I do to one side, I do to the other. I will now have x. Since I divided by a negative, I do flip that inequality symbol, and that becomes -2. Now, we do have the word or right between our two answers. So the question becomes, is this whole thing my answer, right? Well, that you got to determine by thinking of the graph, okay? If they're both pointed in the same direction, it's not going to be both of them, okay? If they're both in opposite, like if you graph both of them and they're in opposite directions, then yeah, you're going to write the whole thing separated with the word or because they're opposite of each other. Let's graph them and see. How do we graph them? You put the smaller number on the left side, the bigger number on the right side. I like to graph with different colors. X is greater than 9, greater than is to the right. X is greater than -2, greater than is to the right as well. Now, anytime you end up with this situation, this is a special case. You got to recognize that your number line, it has 3 parts to it. There's the left part of this first answer. There's the middle part between the two answers, and the right part, okay? So there's 3 parts. And we're talking about the word or, okay? So do I have a red or a blue on the left one, on the left side? I don't have a red or a blue, nope. Do I have a red or a blue in the middle part? Yes, there's a blue one right there. So it satisfies that I have a red or a blue. There's a blue one, so it starts working to the right of -2. Is there a red or a blue over here? Yeah, there's both, right? So it's not over here, it is from here to the right. So all you're going to write is that answer. This is the final answer right here. X is greater than -2. You're not going to mention that one because of the word or, okay? So if they're going in the same direction, with the word or, it's going to be the first one in that direction. So like, let's pretend we would have solved a different problem, and let's say we had -2, +9, and let's say they were both going this way. Well, let me do this one in blue. Both going this way, and it had the word or, then it would be x is less than 9. Does that make sense? Because it's going to be the first one going in that direction. And if you think about the 3 sides, right here, is there a red or a blue? No. Right here, red or a blue? Yeah. So it's from here to the left. Now, if it would have sent, but that's not the case on this one, right? So don't think that's not the case on this one. This one, it's x is greater than -2 because that's where it starts satisfying the word or. Now, if it would have been the word and, then it can't be red or blue. It has to be red and blue, and that would make this one the correct answer if it would have the word and. Does that make sense? I hope so. Let's move on. Here's another absolute value inequality. Half of us got it right, half of us got it wrong. It doesn't matter if you have an absolute value equation or an absolute value inequality. Step one is to isolate it, get it by itself. In other words, there's no 3 times in front that you have to divide by 3 and divide by 3. There's no -2 at the end that you have to go +2 and +2. It's isolated. It's ready to rock. It's ready to do the positive and negative situations. For the positive situation, you simply rewrite it without the absolute values, exactly the way it is. So it reads 5x minus 10 is greater than 5. For the negative situation, you write it exactly the way it is, 5x minus 10, but you have to flip the inequality, put a less than right there, and change the sign of the right side. Make that positive 5 a negative 5, and you change that greater than to a less than, okay? And now you're able to solve both of them. So let's solve the positive situation. You want to get x by itself. You don't want the minus 10. You don't want the multiplication of 5. You start with the minus 10. Get rid of it by doing the opposite, plus 10, plus 10. You end up with 5x is greater than 15, which is really saying 5 times x is greater than 15. The way to get rid of multiplication is division. What you do to one side, you do to the other. You're going to end up with x is greater than 3. Let's do the other one. Likewise, get rid of that minus 10 by doing the opposite, plus 10. We do one side, do the other, plus 10. We have 5x is less than 5. That's really saying 5 times x is less than 5. So you get rid of that by dividing by 5, dividing by 5. Final answer is x. You don't flip it. You didn't divide by negative. X is less than 1. So this is an absolute value inequality. So we need to determine if we're going to keep these answers separate with the word or if we're actually going to put them together as a compound inequality. Okay? So let's put a number line. That's an ugly number line. Anyways, put the smaller number on the left side, the 1 on the left side, the 3 on the right side. I want to graph this one in red. X is greater than 3, greater than is to the right. This one in blue, x is less than 1, less than is to the left. So these areas are apart, which means we're going to keep the answers apart with the word or. So the answer is x is greater than 3 or x is less than 1. It's both answers, and you keep them separate with the word or. Why? Because the areas are going apart. We should know this because we've already even we've looked at graphs and written the absolute value inequality from the graph. And we know that if they're apart, it's going to be a greater than symbol. If they were together, it'd be a less than symbol. Then you'd have to write it together. So side note, if you did solve it and get your 2 answers, and let's say your answers were 1 going this way and a 3 going this way, then you'd have to write them together as x in the middle, smaller number on the left side, the 1 on the left side, and the 3 on the right side with less than symbols. But that's not the case here. Right here, the areas were apart, so we kept the answers apart with the word or. That's how you write your answer. So this did not happen, but if it did, you would write it together the way I just did, but that didn't happen. So I hope that makes sense to everybody. Yay? Okay. Check this one out, 59% average. About a little bit, like 41% of us got this wrong. It's 2 inequalities separated with the word or. So you solve both of them. Right here, you are going to distribute it. They're not absolute values. You're distributing negative 2 times x, negative 2x, negative 2 times negative 1, positive 2. Bring down the greater than, bring down the 6. Then you're going to get rid of the plus 2 by doing a minus 2. What you do to one side, do to the other. You end up with negative 2x is greater than 4, which is really saying negative 2 times x is greater than 4. So you are going to divide by negative 2, divide by negative 2, and you'll get x is less than negative 2. Now we're going to solve the other one. The other one, you happen to have the x on the right side of the inequality. You could isolate it over here, but at the very end, I would flip the whole answer, okay? That's what I'm going to do. I'm going to isolate the x on the right side, and then I'm going to flip the whole answer. So I'm going to get rid of that 7 by subtracting 7 and subtracting 7. My new inequality is a negative 2 is less than negative x. And you could either multiply or divide by a negative 1 to make that negative x a positive x. So you could divide by negative 1 to make it a positive x. But since we did divide by a negative on the last step, you're going to flip that inequality symbol from a less than to become, or from a less than to become a greater than. And you end up with a positive 2 on this side. Now, this is the answer. However, you don't want to talk about 2, you want to talk about x. And right here it says 2 is greater than x. You want to read it backwards, or you want to flip the whole thing so you could talk about x. So put the x on this side, the 2 on that side, which means that it's going to flip again. It's going to stay open. It's going to stay open to that 2. So you have those 2 answers. And we need to know whether we keep both of those answers with the word or between it, or do we just write one or the other with respect to that word or. So, let's graph it. Number line, smaller number on the left side, negative 2 on the left side, positive 2 on the right side. I'm going to graph this one in red. X is less than negative 2, less than's to the left. This one says x is less than 2. I'm going to graph that in blue, less than's to the left. It is the word or. So what am I going to write as a final answer? Do I write both of them? No? Which one do I write? X is less than 2. Only the blue one. Again, the word or, think about it. You got 3 areas. You have the left, the middle, and the right. On the right, is there a left? On the right, is there a blue or red? No. In the middle, is there a blue or red? Yes, there's a blue. Over here, is there a blue or red? Yes, there's both. So where does it start satisfying the word or? To the left of positive 2. And that would be x is greater than 2. So this is your answer. You don't write or, you don't write that one. It's just x is less than 2. Last one here, especially because it's almost identical to the other one. This one says, if you were solving compound inequality, 2 inequalities separated with the word and you get those 2 answers, x is less than 1 and x is less than 5, what are you going to write as a final answer? You just have to simply think about that number line. Smaller number on the left side, bigger number on the right side. X is less than 1 is going to the left. X is less than 5 is also going to the left. But it has the word and between it. So what would your final answer be? X is less than 1. Why? Because you got 3 sides, the left side, the middle, and the right. And if you think about the word and, on the right side, do you have a red and a blue? No, you don't have any. In the middle, do you have red and a blue? No, you only have a blue. Over here on the left side, do you have red and blue? Yes. So it starts satisfying this statement with the word and to the left of 1. So that means that your only answer is this guy, not that. Simple as that. I hope that makes sense. I hope you guys study over the weekend. And I hope you guys come in after school Monday to retake this to get a better grade.